Solving problems using primary trigonometric ratios. In this video, we're going to take a closer look at how to use primary trigonometric ratios and their reciprocals. There are three primary trigonometric ratios that can be used to solve problems. Here is a basic diagram that we're going to work with. You would be given a right-angled triangle, a reference angle, which we'll call theta. We will label the side opposite or across from the right angle the hypotenuse. The side across from the given angle, we'll call it, of course, opposite. And the side that's close to angle theta, we'll call adjacent. The three primary trigonometric ratios are sine theta is equal to opposite divided by hypotenuse. Cos theta is equal to adjacent divided by hypotenuse. And tan theta, which is opposite divided by adjacent. The three reciprocal trigonometric ratios are the cosecant of theta, which is 1 over sine theta, which is equal to 1 over opposite divided by the hypotenuse. You can also have the secant theta, which is 1 over cosine theta, which is equal to 1 divided by adjacent over hypotenuse, or the cotan theta, which is 1 over tan theta, which is equal to 1 divided by opposite over adjacent. Another way of stating these reciprocal ratios, the cosecant theta is equal to hypotenuse over opposite. Secant theta is hypotenuse over adjacent. And cotan theta is adjacent over opposite. Now, let's take a look at a sample question. From an army tank, the angle of elevation to the top of a 15-meter tower is 15 degrees. After advancing toward the tower, the angle of elevation is 25 degrees. How far did the tank advance? Now, let's take a look at the solution. First, we're going to create a sketch, and of course, we're going to label the sketch. We'll start with the 15-meter tower. We'll measure out a distance where we'll put the tank at position A. The angle of elevation to the top of the tower from tank A is 15 degrees. Now, the tank advances. From this position, the angle of elevation is 25 degrees. What we are trying to find is the distance between point A and point B. What comes next? Now, write an expression for the initial distance from the tank at position A to the tower at position X. Now, AX is the adjacent side to A, and the tower is the opposite side to the tank at position A, so we will use tan theta, which we know is 15 degrees. So tan 15 degrees is equal to opposite divided by adjacent, which is 15 divided by AX. So we will cross multiply. AX will be equal to 15 divided by the tan of 15. Leave your answer in this form for now. Now, let's take a look at the expression for the new distance, the distance from the tank to the tower, which we'll call Bx. Now, we will still use the tan ratio, but the angle of elevation is now 25 degrees. So the tan of 25 degrees is equal to opposite divided by adjacent, which is 15 divided by Bx. Bx then is equal to 15 divided by the tan of 25. Again, leave your answer in this format. Now, to determine the distance the tank advanced, you will take the distance AX and subtract the distance BX. So AX we said is 15 divided by the tan of 15 degrees. Subtract the distance of BX, 15 divided by the tan of 25. Using your calculator, that will equal 23.8131 and so on. But let's round it off to approximately the answer of 23.8. And now, state the conclusion. The tank advanced approximately 23.8 meters. Now you are ready to complete Project 1, Task 1. But first, the next video.